All right, I'm going to cover chapter 9 in this review video. This is the introduction to significance tests. So, in a significance test, we're taking and assessing evidence against the null in favor of an alternative hypothesis in terms of the parameters mu, p, beta. Assuming the null is true, the p value tells us the probability that our result or something more extreme just occurs by chance. And we know if the p-value happens less than alpha, if that probability is lower, we reject the null, and we have convincing evidence for the alternative. So in terms of errors that we can make, we know that we can make a type 1 and type 2 error. I like this little table. This is if the null is true, if the alternative is true, and then here's our decision. Are we rejecting or failing to reject? If the null is true and we reject it, that's a type 1 error. If the alternative is true and we fail to reject that, that's a type 2 error. If the alternative is true and we correctly reject the null, that is called the power. That's a good thing. And then if the null is true and we fail to reject, that's the correct decision. It doesn't have a specific term. So two ways we can increase the power of the test are to increase the sample size or to increase the significance level. The problem is alpha is the probability you make a type 1 error. So if alpha goes up, the probability you make a type 1 error goes up. So let's look at the structure of these intervals for a one sample t interval. I'm just using my formula sheet here. Means, one population. There's your statistic. There's your standard error. And anytime you have a means, you're going to be using the t distribution. And then for proportion, same deal. One proportion, there's my statistic. There's my standard error. So that's where that's coming from. For a test statistic, it's statistic minus parameter divided by the standard deviation. So it's just going to be the sample mean minus what you've claimed in your null divided by the standard error. Same idea for test. This is a little different though. It's going to be the sample proportion minus the null value. Now here we're not going to use the standard error that we did in the confidence interval. Why? Because we know we have an assumed value for the true proportion, so we use that instead. And that's what this little asterisk means at the bottom of this page if you've read that. Let's look at an example. All right, Mr. Wilcox took a random sample from all stat students he's ever taught. Assume the distribution of these scores, both scores on the diagnostic and the AP are approximately normal. And you can see there's these two. So it's the same student taking the diagnostic and the AP. So this is a matched pairs experiment. So what we're going to do is take a look. Do we have significant evidence that the scores have improved? So in order to figure that out, I'm going to look at the mean difference. So the null is going to be the true mean difference in the score. You could set up the subtraction either way. I chose to do the AP minus the diagnostic. So the mean would be the mu diff is 0. The mean difference is 0. And the alternative would be that we think the scores have improved from the diagnostic to the AP. So this would be greater than 0. CVS, random 10% normal condition. They told us the population distributions were approximately normal, so we don't need to make any box plots. So the conditions are met. We're going to do a paired t-test. The degrees of freedom are 9. We have 10 pairs minus 1. So I have this list of differences. It would be like 1, 1, 0, etc. It's just the AP minus the diagnostic. And then what I'm going to need to do is calculate the one variable statistics on that list so that I can get the mean difference and the standard deviation of the differences. In this case, 0.7 and 0.67. So the test statistic is going to be 0.7 minus 0, the statistic minus our null divided by the standard error is 3.28. I can use TCDF to get a p-value. The p-value is 0.005. That ties into the conclusion. That's less than 5% of the time. So we're going to reject the null. So we have convincing evidence that this true mean difference is greater than 0. Follow-up questions. What kind of error could you have made? A type 1 error. If you reject the null, that's a type 1. They could ask about the p-value in context as well. That's if the null is true. In this case, there's a 0.005 probability of getting a sample result of 0.7 or higher purely by chance. All right, that's it for chapter 9.